Let's prepare on channel slopes classification. In the previous lecture, I have told you that next lecture will be on gradually varied flow. So there is a small topic left over there. So we'll just see that and we'll be going to the next topic, that is your classification of channel slopes. So here we already know what is gradually varied flow, a steady non-uniform flow where depth changes from section to section gradually is called as gradually varied flow. So here when you take the dy by dx as slope in that flow, it is given by this formula. So just see this formula because they'll be asking this in the questions. So here SF is your energy slope, SW is your water surface slope, and S0 is your bed slope here. So here S0 minus SF by 1 minus Q square T by GA cube. So here we know that this term, that is Q square T G A cube. So when you expand this, you will be getting the Froude number. We have already done this derivation in the previous lecture. So we can write this formula like this. So this is an important formula, and it can also be written as the IB minus IE by 1 minus V square by GH. That is the bed slope and the slope that is actually happening in that energy flow. Okay, so that two slopes. The S term is denoted as I here, and this Froude number is expanded here and written here. That's the simple difference here. So with this, they may ask you the question. So this is an important formula here. And with the value of this dy by dx, we can identify what type of flow is happening in that gradually varied flow. That is, when it is less than 1, it is actually a drawdown curve happens there, and if it is equal to 0 means a uniform flow is moving, and if it is greater than 1 means a backwater curve is occurred there. So this is how we can classify the curves of the water flow with respect to this slope value. The next thing we are going to see is the classification of bed slope. So here there are 5 types. The first one is critical slope, which is denoted as C here. Okay. And here SC, SB and all, what means? SC is your slope of your channel, that is your critical slope of your channel, and SB means it is the normal slope of your channel. It is a bed, no, so they are denoting here B. You can also denote it as SN also, like this also you can denote it as. So it is the normal bed slope, and SC is your critical bed slope, and here YN and YC means it is the normal depth and critical depth respectively of that flow. So here the first case is your critical flow, which is denoted as C. So here when the slope is equal to SC, we will be calling it as critical slope, and in that point YC will be equal to YN. Critical depth and normal depth will be equal. So just see this tabulation once, then we will be seeing each and everything in detail also. Okay. The next thing is your mild slope, which is denoted as M, and here the bed slope will be less than the critical slope, and the normal depth of that flow will be greater than the critical depth. So here the flow will be a subcritical flow generally, and in the previous case it is a critical flow, in this case it is a subcritical flow. The third thing is the steep slope, so which we denote it as S. So here the bed slope will be greater than the critical slope, and the normal depth will be less than the critical depth. So here in the steep slope the flow will be supercritical flow. And the fourth type is the horizontal slope. So there is no slope provided, just the horizontal bed channel is given. So here SB will be equal to 0, that is slope is 0 only. So YN will be equal to, that is the depth of the flow will be equal to infinity. And the fifth one is adverse slope, so which is denoted as A. And here SB will be less than 0, slope will be less than 0, and the YN will be imaginary, so it cannot sustain a uniform flow. So these are the general definition for this classification of bed slopes. So now these 2 points, how this infinity and imaginary comes, let us see that. So if you take the horizontal slope, Q is equal to AV, and AV I have expanded with respect to the Manning's formula. So you can write this whole term as f of y. Okay, leaving that s alone, slope alone, I have taken it as f of y, and s power 1 by 2 it is root s. So Q is equal to f of y into root s. So you can write f of y is equal to Q by root SB, that is your slope of the bed. So now in this horizontal channel, the slope of the bed is 0. So something by 0, you'll be getting infinity only. So your function of y will be equal to infinity. So y is equal to infinity here. So in the adverse slope also the same thing is done here and the same thing is done here. So when you assume SB is negative, that is less than 0, infinity, root of negative value will be, it's not infinity, it's imaginary. Root of negative value will be imaginary term. So obviously yn is imaginary, which can't exist. Okay, so this is the how they calculated or they derived the relation between the slope and the normal depth and critical depth, everything. So before going into the single thing in detail, we'll be seeing some basic definitions here. So normally a supercritical flow and subcritical flow means, it's what means the normal depth line, that is the normal depth of a water, no? So if it is more than the critical depth line, the flow is said to be subcritical flow. So this is your normal depth line, this is your critical depth line, and this is your bed line, that is your bed level. So when it is greater than, normal depth line is greater than CDL means it is subcritical flow. When your critical depth line is greater than normal depth line means it is your supercritical flow. So here the first one is your critical slope. So we know that in critical slope the yn will be equal to yc and s also will be equal to the critical slope only. So here the normal depth line will be equal to the critical depth line in this case. So now we can classify this slope, that is the critical slope itself can be classified into two types. So how to classify means you have to take a depth above the line and below the line of the critical depth line. So here if you take one point here and one point here, what happens in one category, y will be greater than yn or yc, and the next category y will be less than yn or yc. So it is classified as C1 and C3. Okay, so C1 is nothing but the subcritical flow and C3 is your supercritical flow here. Okay, so if there is two different lines like this NDL and CDL means we'll be taking a point in between that also, but in this case we cannot take that, so only here C2 is not coming. Okay, so this C2 does not exist here. So this is an important point to be noted, because out of all these classifications some three category alone will be cannot be existing, so that they may ask you. So this here in here C2 is does not exist, so that is important. And this C1 and C3 profile, no, so this is very highly unstable and they occur very rarely only. And the second one is your mild slope. So we denote it as M here. So mild slope means yn will be greater than yc. So you are getting NDL will be greater than CDL here. So we can take 3 points here. 3 points of y you can take it here, and here yn also is greater than yc. Okay, so here when you take this point, it is classified as M1, where your y is greater than yn and yn is greater than yc. So these conditions are important. And in M2 yn will be greater than y and greater than yc, and in M3, that is this point, yn will be greater than yc and which is greater than the y we take. So these are the conditions, that is M1, M2 and M3. So what are these conditions and where does this occur? So that also we need to see. So M1 profile is a backwater curve due to the obstruction to flow such a weir or dam, etc. So when there is obstruction, a backwater curve will be formed, no? So that will be the M1 profile. So M1 profile will be like that only. And M2 profile, so normally M1 profile will be like this. So above the normal depth it will be moving like this. Okay, and then M2 profile at a sudden drop in the bed of the channel. So when there is a sudden drop in the bed of the channel, M2 will be happening. So it will be flowing like this, sudden drop will be happening. So this is your M2 profile. And M3 profile is the flow through a sluice or any spillway. So when there is a flow through a sluice or spillway, it behaves like M3 category, and the profile or the diagram for that will be like this, M3 category. So these are the M1, M2 and M3. So here M1 is your subcritical flow, M2 also will be subcritical, but M3 alone will be supercritical flow. So this is also important. I have not written that here. So whatever I tell you, that is subcritical, supercritical and the examples also, you just note down along with this, so it will be useful for you. The third category we are going to see is the steep slope. So in steep slope, the yn will be less than yc, and so here we got CDL greater than the NDL, and here also we take 3 points here. So if you take the first point, you can categorize it as S1 where y is greater than yc, which is greater than yn, and second point S2 where yc is greater than y greater than yn, and the third point, this point, yc will be greater than yn, which is greater than y. So these are the three categories we can take, S1, S2 and S3. So now the example for S1 is, so when a flow from a channel is coming and it is suddenly terminated by a weir or some any obstruction, if you are keeping there, means a jump will be happening. So this hydraulic jump or this jump of water only is the first category, that is your S1. So the flow or the profile will be like this, it will be increasing accordingly like this. And the second case, that is S2, no. So where this S2 occurs means when there is the entrance region of a steep channel flow. So when you have a steep channel like this and the water enters here, no, so this flow will be like this. So this flow is your S2 profile. So the profile could be drawn like this, S2. It suddenly flows through that steep channel. And the third profile, S3. So for this, the example is at the toe of the sluice gate with a steep slope. So sluice gate means we know gate will be there and the water will be left from the bottom only, it's not from the top. Okay, gate means they'll be opening this, so the water will be coming here. So it will be increasing like this, no. So that profile is only called as S3 profile. So the diagram for that will be like this, S3. So this is your S1, S2 and S3. So out of these three, S1 is your subcritical flow and S2 and S3 is your supercritical flow. And the fourth one is your horizontal slope where yn is equal to infinity. So we have drawn the normal depth line as a infinity. Sorry, it's not imaginary here, it is infinity. And yc will be less than that, that is the critical depth line will be less than that. So here we can't take a third point, that is a point above this, so which we usually take it as first point, no? So we can't take that because the NDL itself is an infinity point, so how can you assume a height above that? So we can't take that. So here H1 does not exist, so this is an important point. So here H2 and H3 profile only exist. There in H2 yn will be greater than y, it is greater than yc, and in H3 yn will be greater than yc, which is greater than y. So now the examples for H2 and H3, no. So this is similar to the M2 and M3 profile only, but the only difference is the slope is horizontal here. Okay, so you can take the same examples there, but the slope is horizontal here because the profile of that this diagram, that is H2 and H3, will be similar to that. So the profile will be for H2 it will be like this, and for H3 it will be like this. So which is we saw similar to the M2 and M3 but in the reverse direction, that's all. Okay, so here in H3 the hydraulic jump is possible when there is y is less than yc, no. So there is hydraulic jump is possible in this case, that is H3. And according to the slope, that is flow, here H2 will be subcritical and H3 will be supercritical flow. And then the last one, fifth one, is the adverse slope. So here yn is equal to imaginary. So here also the NDL line is imaginary. So we can't assume 1. So here A1 does not exist here. So this is an important thing. And in this 2 and 3 exist. So A2 y is greater than yc, and in A3 yc is greater than y. So yn is imaginary, so you can't bring that in this relations. Okay, so now the flow that is in this adverse flow will be A2 will be subcritical and A3 will be supercritical flow. Okay, and then here as the S naught is very less, no, that is, it is less than 0. That is what we assume in adverse slope. So here the channel bottom rises in the direction of the flow, because the channel will be like this. Okay, so it rises in the direction of the flow. So this is an important condition to be noted. And these are all about your different classification of slopes, and there is also combination of slopes also occurs. So combination means any two profile will be mixed. For example, if you take M2 and S2, M2 means what? It is a mild slope. So it is a mild slope will be provided here, like this, a mild slope, and S2 is your steep slope. So like this, a profile may be combined, and like this also it may be combined, mild slope and then a horizontal slope, mild slope, horizontal slope, and then a steep slope. Okay, so why these combinations are given means, when you profile, when you fix a mild slope and then if you provide a horizontal slope, means automatically the water level will be increasing there. So when you want to rise the water profile, you can use this methods to do that combination of slopes. So the best profile combinations like that, two best profiles are there. So just note this, M2 S2, just now I told you, no, mild slope and steep slope. So M2 and S2, M1 mild slope and then horizontal slope H2 and S2. So these are the combination. This is one combination and this is another combination. So these two combinations are known as best profiles to be applied practically. Okay, and also we have seen the profile which does not exist. No, so there are three profiles, that is C2, H1 and A1, that is critical 2, horizontal 1 and adverse 1. So these three categories does not exist in the practical thing. So that is also very important, they may ask you this. So this is all about your classifications of bed channels. Thank you and keep watching for the next lecture on dimensional analysis.